going to try and do the difference quotient today, and it seems like a nice thing to do, so I had to erase some things. Let's pick a pencil and look at what the difference quotient actually is. It's discussing the slope of a particular function. It doesn't have to be a function, but we're going to say it's a function, so we're going to say f of x is going to be, I'm sorry about that, but I haven't got this thing trained very well. Of course, f of x is y. Anyway, we're going to say it's 1 over x squared. So, well, we could go through all the stuff that looks like, but that's another lesson. So it looks something like this. Whoop, it's got to go down a lot faster than that. It's going to be 1. It's got to be 1. Right, because when x is 1, y is 1. So, let me take a minute and erase that. So it's not distracting, and we want to find the slope of a tangential line. Okay, so somewhere, let's say right around there. So it's got to be tangential, right? And it's just going to be one point. There's a line only that intersects this curve in one point. So we look and we see that it appears at that point is right around here. How do we go about doing the slope? Well, we know the slope is m is the delta y over, excuse me, again I'm not used to this pen, delta x. Well, that's another way of saying that it's, since y is a function, let's say that's the f of the x plus an increment a minus, and of course this is delta y, f of x itself. So as it's added a, the function has a difference. And if you look, you see that x plus a minus x is just going to be x. Did I say that correctly? I hope I wrote it correctly. X minus x is a. So again, that's a change in x. So then in our diagram, we're looking at this as being x. That's there is x plus a. Okay, so then what we're doing is we're looking at the f of x. But remember, the f of x for this point is going to be right there, and the f of x for this point is going to be right there. And of course, those are y. So this is going to be our change. So we can see that as we're going to the right, the function is dropping, that's for sure. Well, what's interesting about this is all we have to do is plug this in. So I have the fact that f of x plus a is literally 1 over x plus a squared, and it's minus 1 over x squared naturally. So when I look at this, then I see that I'm going to be over a, and to help make this a fraction, I'm just going to put a over 1. So as I do my LCM, you see that my LCM is going to be the x plus a squared, so that of course is x squared plus twice ax plus a squared, and that's going to be being multiplied by x squared. So my numerator then, since it's a 1, is quite simply x squared, and it's minus all this. So what happened there? Minus a squared. Notice that the x squareds go away, and if I factor out the minus 2a, actually I only need the a, so I'm just going to take the a. That leaves me with minus 2x and minus a. All right, and that's all over all this. It's over all of that, right? So I'm just going to say it's over all that. That goes right there. Now this, I'm going to flip, right? So I have 1 over a here, because we're inverting and multiplying. And now when I cancel my a, I see that my slope is minus, and let me find this spot to write this. So make a big spot here. My slope of this function is quite simply minus 2x minus a over, and this multiplied out, I'm going to go ahead and do it, x to the 4th plus 2ax cubed, and we'll see what's going to happen to that pretty soon. And this back here was definitely a plus sign, plus a squared x squared, right? Well, so you think, well, that sure looks a lot different than what we had at the first, and that looks kind of like a nice slope, but look what happens when we take the limit as a approaches x, or goes to 0. We see that this ends up being a minus 2x, which we anticipated since it's going down, over x to the 4th, which of course simplifies to just minus 2 over x cubed. And isn't that nice? That's the actual slope at any given point x of this function 1 over x squared. And that concludes this lesson.